This is just a sample of the training available at itdvds.com. To see complete training, please go to itdvds.com. Let's begin the sample. In order to network computers or devices together, we need to connect them to some sort of networking device. And those networking devices are going to be hubs, switches, bridges, and routers. So first let's talk about what a hub is. And you can see this is a hub that we would normally plug an Ethernet network cable into. And this is a picture of actually a Netgear hub. Hubs are very rare nowadays. We used to use hubs long time ago, but now we use switches. And let's talk about why that is. First of all, a hub is a repeater. So when we plug, let's say we plug a computer into this port, computer into this port, and we have 4 computers connected to this hub, let's say, 1 in each port. Well, when a computer tries to communicate with another computer, it's going to send information over the Ethernet cable. It's going to hit the hub, and then the hub is actually going to forward that information out all of the ports. And this is very inefficient and actually can cause a lot of problems and can cause collisions. And we're going to talk about collision domains a little bit later on. But let's say the computer that's plugged into port 1 is trying to communicate with the computer that's plugged into port 4. Well, again, it's going to forward that information out all of the ports. Wouldn't it be nice if it just forwarded that information out port 4? Well, that's actually what a switch does. And that's why we use switches now. And hubs function at layer 1 of the OSI model. Now, we're going to be talking about the OSI model later on, but this is something we'll need to burn into our brain, that hubs function at layer 1. Hubs also create 1 collision domain, as I mentioned, and 1 broadcast domain. And very briefly, a collision domain is basically a connection or connections where information can collide with other information. So, for example, let's say we got 4 computers plugged into each one of these ports. Computer 1 here is trying to send information, and at the same time, computer 4 is trying to send information. Well, that information will actually collide if they try to send it at the same time. And then that information will have to be retransmitted. And there's a protocol that Ethernet uses called CCNA/CD, and we'll talk about that later on, but that helps with this whole collision and retransmit process. But the bottom line, it's very inefficient when a collision happens, and it's also another reason why we don't use hubs. And switches actually break up collision domains. Which brings us to switches and bridges. Now, switches and bridges are effectively the same thing. There are a few minor differences that we're going to talk about here in a second. But the bottom line, as far as we're concerned, is we use switches or we use bridges. And realistically, nowadays, we use switches. Bridges were actually what we used to use when we had hubs in our environment. And the reason we used to use them is to break up collision domains. But now we just use switches. Switches have as many ports as hubs do, and we don't even have to use bridges because switches actually break up our collision domains as well. In fact, each port in a switch is a collision domain. But we also need to know that they don't break up broadcast domains, and again, we'll get into that, but I just want to mention it here. And switches actually forward frames based on the MAC address table. So it keeps a table of MAC addresses, and that's how it knows where to forward a frame, which remember is information, out a certain port, so that it's not just forwarding that information out all of the ports. Let's take a look at a switch real quick. Here's a Cisco switch, and you can see it has quite a few ports on it. So let's say I've got a computer plugged into each one of these ports. And the computer in this port is trying to send information to the computer in this port. Well, the switch is not going to forward that information out all of these ports. You can imagine how inefficient that would be. It's going to use the MAC address table, and remember, all Ethernet networking cards that are in our computers have a MAC address burnt into them. So we don't actually set that MAC address. So it's going to use this MAC address table to say, oh, well, this computer is connected to this last port, so I'm just going to forward that frame out this port. And that's very, very efficient. And you can actually, here's the back of the switch. You can see it just has a console connection. We're going to talk about console connections a little bit later. But it's basically how we can hook like a laptop directly up to this switch and program it and communicate with the Cisco IOS. Now, switches function at layer 2 of the OSI model. Again, this is something we just have to burn into our brain. Switches function at layer 2. And there are some important layer 2 functions here that a switch does. It's address learning, forwarding and filter decisions based on MAC addresses, and loop avoidance. And address learning is the learning of MAC addresses so that it knows which port to forward information out. Forward and filter decisions, we can actually set up rules that say forward certain data or don't forward certain data based on MAC address. And loop avoidance. And this is something we'll get into when we talk about the spanning tree protocol. And again, each port in a switch is a collision domain. That's very important. Now let's talk about routers. Routers perform packet switching, filtering, and path selection. So routers will actually move packets of information from one network to another network. We can filter information going through the router by IP address. So we can say, yes, this information can be forwarded on, or no, this information cannot be forwarded on. And routers also perform path selection because we can actually have multiple paths to get to a whatever destination that information is trying to get to, and routers will pick what they think is the best path. Routers function at layer 3 of the OSI model, so we need to burn this into our brain, layer 3. And routers break up collision domains and broadcast domains. So let's just take a look at a network diagram real quick. Let's say we have two offices here. This is one office, this is another office, and we have our computers. Our computers are connected to a switch, and then that switch is connected to a router. And that router can be connected over a WAN to another router, and then that router is connected to a switch, and then that switch is connected to computers. And these very well could be hubs, but again, nowadays, they're most likely not going to be hubs because of reasons we talked about. They're very inefficient. And finally, remember we said switches and bridges are effectively the same thing. Real quickly, let's just talk about some of the differences. Bridges are software-based. Switches are hardware-based with an ASIC chip. Only one spanning tree instance per bridge. Switches can have many. And spanning tree has to do with loop avoidance, and we're going to get in depth into spanning tree later on. And switches normally have more ports than bridges. And that's actually why we use switches.